Achieving this level of system efficiency renders the strategy of restricting single high-end chips obsolete. In 2022, the United States imposed hardware sanctions meant to stall China's artificial intelligence industry by cutting off access to the world's most advanced microchips. Instead, these restrictions pushed Chinese engineers to develop a new infrastructure that does not rely on the flagship silicon produced in the West. The U.S. embargo specifically targeted this model. By restricting exports of the manufacturing equipment and the wafers needed to build these components, the U.S. intended to starve Chinese data centers of the raw compute required to run high-parameter models. But cutting off the hardware supply line did not end the race. When a country is blocked from the high-end hardware required to follow one model, the incentive shifts to redesigning how AI performance is measured entirely. To bypass the need for restricted silicon, engineers deployed supernodes. This diagram shows the logic of the workaround. Instead of relying on one massive restricted processor, like the node on the left, a supernode lashes together thousands of mid-tier domestic chips into the interconnected web on the right. Linked together, they match the total output of a single US superchip. For this to work, the software must route data packets between these thousands of discrete components with microsecond synchronization. This high-speed coordination across the web allows the network to compensate for the hardware limitations of any individual chip inside it. Beyond the hardware was only the first step. During the conference, the International Data Corporation released a report that formally shifted how the software itself is appraised. They introduced a new global standard called Daily Active Agents, or DAA. This counts AI programs designed to autonomously execute multi-step tasks, rather than just generating text in a chat window. This chart contrasts DAA with the Silicon Valley standard. On the left, token burning tracks how much compute is used, even if the output is low. On the right, the daily active agent metric focuses strictly on successfully completed tasks, measuring what the AI actually accomplished. The metric to daily active agents moves AI out of the laboratory. It demands that these digital tools act as accountable engines that drive the actual economy. This focus on practical output has already moved from data centers to the factory floor. These digital agents are now being integrated directly into physical machines. While early humanoid robots performed routines for cameras, these new models are programmed as agents to execute complex industrial instructions. They can now organize supply rooms and manage entire segments of a production line. Baidu's Apollo Go autonomous vehicles have moved beyond domestic use, with new agreements signed to expand their robotaxi services into Central Asia. By moving AI capabilities out of the chatbot window and into the physical economy, China is securing a tangible manufacturing advantage, building a workforce that operates at machine scale. This map shows the 29 nations making up the initial coalition, concentrated across South America, Africa, and Asia. For these global South regions, the Western AI ecosystem is often out of reach. China is positioning its supernode clusters and task-oriented agents as a practical alternative. While the US focuses on developing powerful, isolated models in a lab, China is hardwiring its industrial AI systems into the global economy.